the speed of light, the fastest speed anything can ever reach, the journey is already too late. That is the unsettling truth. Not difficult, not far, not someday, too late. Right now, as you are watching this, the universe is quietly pulling other galaxies away from us, not slowly, not gently, but relentlessly, faster and faster every second. There are places in the cosmos that no human will ever reach, not because we lack better rockets, not because we need more time, but because reality itself has already closed the door. This is not science fiction. This is modern physics. For decades, humans have believed in one idea, that no distance is truly impossible, that with enough intelligence, enough technology, and enough time, we can go anywhere. First across oceans, then to the moon, then to Mars, and one day, beyond our galaxy. The dream is simple: become an intergalactic species. But here is the part most people never hear. Some of the smartest physicists alive say that dream may be fundamentally impossible, not difficult, not far away, impossible. Among them is Greene, a leading voice in modern physics and cosmology. He has spent years studying the deepest laws of the universe, space, time, gravity, and the structure of reality itself. And his conclusion is not comforting. The universe has limits, hard limits. And those limits are not suggestions. They are rules that cannot be broken. In this video, you're going to understand something that changes how you see space forever. You will learn why distance is not the real problem. You will learn why even the speed of light is not enough. You will learn how time itself becomes an enemy on intergalactic journeys. And most importantly, you will discover why the universe is actively working against us, making some destinations permanently unreachable. There are facts in this story that most people have never heard. For example, the nearest large galaxy to us is over 2 million light years away. That means even light moving at the fastest speed allowed by physics takes more than 2 million years to get there. That is not a travel time. That is a wall. And it gets worse. The universe is not static. It is expanding. Galaxies are not sitting still, waiting to be visited. They are moving away. In many cases, they are moving away faster than light itself due to the expansion of space. That sounds impossible, but it is real, and it changes everything. This means that even if humanity somehow builds a ship that can travel near the speed of light, many galaxies would still remain out of reach forever. The destination is not just far, it is running away. There is also a hidden cost to speed. As you move faster, the energy required does not increase in a simple way. It grows dramatically. Pushing an object closer and closer to the speed of light demands more and more energy until the requirement becomes infinite. That means no matter how advanced a civilization becomes, it can never actually reach that ultimate speed. So the one thing that could make the journey possible is the one thing that physics does not allow. But there is another twist. Time itself begins to behave in strange ways at high speeds. A traveler moving close to the speed of light experiences time differently. Minutes for them could be years or centuries for everyone else. This sounds like an advantage, but it comes with a devastating consequence. Even if someone could survive the journey, everything they knew would be gone by the time they arrived. Civilizations would rise and fall, stars would change, entire worlds could disappear. The journey would not just be long, it would erase the meaning of return. And then there is the environment between galaxies. It is not empty in the way people think. It is filled with radiation, particles, and dangers that become deadly at extreme speeds. Even a tiny grain of dust, when hit at near light speed, carries the energy of an explosion. So the ship must survive not just time, but constant invisible threats for millions of years. Now consider this. Even the most advanced ideas humanity has imagined, like warp drives or shortcuts through space, remain theoretical. They require forms of matter and energy that may not exist, or cannot be controlled, or cannot be sustained. These ideas solve equations on paper, but they do not yet solve reality. And that brings us back to the central question. What if the universe itself says no? Not because it is hostile, but because it is built this way. Because the laws of physics define what is possible and what is not. And those laws apply everywhere, to every civilization, to every technology, no exceptions. This video will take you step by step through the real reasons behind this cosmic limit. You will see how distance, speed, time, and the expansion of the universe all combine into a single barrier. A barrier that no engine can break. A barrier that no intelligence can outsmart. A barrier that may define the ultimate boundary of human exploration. By the end, you will understand something very few people truly grasp. The universe is vast, but it is not fully open. Some frontiers are not waiting to be crossed. They are already closed. If you want to explore the deepest truths of space, the hidden rules of reality, and the discoveries that most people never hear about, make sure you subscribe to the channel and stay with us until the end. The first barrier is distance, not the kind of distance measured in kilometers, not even the kind measured across planets or star systems. This is a scale that breaks the human mind. Our home, the Milky Way galaxy, is already enormous. It stretches across about 100,000 light years. That alone is almost impossible to fully grasp. Light moving at the fastest speed allowed by nature takes 100,000 years just to cross it. And yet, this is only our neighborhood. The nearest major galaxy to us is the Andromeda Galaxy. It sits about 2.5 million light years away. That number sounds simple, but it hides something extreme. It means that even if you travel at the speed of light, the journey would take 2.5 million years. Light itself needs millions of years to get there. Now compare that to anything humans have ever built. The fastest spacecraft ever created is the Parker Solar Probe. It reaches speeds of about 700,000 kilometers per hour. That sounds incredibly fast. On Earth, that speed could circle the planet in minutes, but in space, it is barely moving. At that speed, reaching the nearest star system, Proxima Centauri, would take thousands of years, not millions, just to reach the closest star. To reach another galaxy, the numbers become absurd. At current spacecraft speeds, the journey to Andromeda would take tens of billions of years. That is longer than the age of the universe itself. The universe is about 13.8 billion years old. The trip would outlast it. This is where reality starts to feel unforgiving. Even if humans could build a ship 1,000 times faster than anything today, the journey would still take millions of years. That is not a mission. That is a time scale where entire species rise and disappear. Human civilization, as recorded, is only a few thousand years old. Written history is even shorter. Technology changes drastically within decades. Now stretch that timeline to millions of years. No system built by humans has ever lasted anywhere close to that. A spacecraft would need to survive for longer than civilizations exist. It would need to function without failure for millions of years, no repairs, no resupply, no margin for error. Even biology becomes a problem. Human bodies are not designed for such journeys. Generations would need to live and die inside a machine, far from any planet, far from any natural environment. Entire societies would exist only to continue a journey they would never finish. And even that assumes everything works perfectly. One small failure, one tiny breakdown, and the mission ends in silence, lost in a void that stretches across millions of light years. There is another detail that makes this even more severe. Space is not filled with shortcuts. There are no hidden paths between galaxies, no natural bridges, just vast emptiness. The distance is direct, open, and unavoidable. This means every meter of that journey must be crossed the hard way, step by step, year after year, century after century, until the scale, becomes overwhelming. Distance alone creates a barrier that feels absolute. And this is only the beginning of the problem. Distance alone feels impossible. But there is a deeper rule that makes it worse. The universe has a built-in speed limit. It is not a suggestion. It is a law. That limit is the speed of light, about 300,000 kilometers per second. Nothing in nature moves faster. Every signal, every particle without mass, every piece of information is bound by this ceiling. This is where things turn harsh. Anything with mass cannot reach that speed. Not a spaceship, not a human, not even a single atom. As an object moves faster, its energy does not rise in a simple way. It grows more and more extreme. Pushing closer to the speed of light demands more energy than before, then even more, then far more. Near that limit, the energy required begins to explode. To reach the speed of light, the required energy becomes infinite. That is not a large number. That is a physical impossibility. No engine can generate infinite energy. No fuel source can supply it. No advanced civilization can bypass it. This is written into the structure of space and time itself. Even getting close to that speed creates problems that are hard to survive. At a small fraction of the speed of light, tiny particles in space turn dangerous. Dust grains, smaller than a grain of sand, become high-energy projectiles. At extreme speeds, a single impact can release energy like an explosion. The faster the ship moves, the more violent these impacts become. Space begins to behave like a minefield. Radiation also becomes more intense. As speed increases, incoming radiation shifts to higher energy. It becomes more harmful. Shields would need to be far beyond anything humans have ever built. And they would need to last for millions of years without failure. Then comes the challenge of acceleration. Reaching even a fraction of light speed requires enormous force over long periods of time. That force affects everything inside the ship. Humans, machines, structures. Too much acceleration and the body cannot survive. Too little and the journey stretches even longer. There is also the problem of heat. Engines powerful enough to push a ship to such speeds would generate extreme temperatures. Managing that heat in deep space where there is no air to carry it away becomes another major obstacle. Every solution creates another problem. Every step closer to light speed multiplies the risk. Some people believe future technology will solve this. That better materials, stronger engines, or new physics will break the barrier. But this is not like improving a car or building a faster plane. This is a limit defined by the universe itself. The equations that describe motion, energy, and space all point to the same conclusion. The speed of light is not just fast. It is final. No upgrade can change that. So even if distance could be ignored, even if time did not matter, there is still this wall. A hard boundary that no object with mass can cross. And even approaching it turns space into something far more dangerous than empty, which leads to another strange consequence. When you move close to this limit, time itself begins to change. As speed rises closer to the limit, something unexpected begins to happen. Time starts to bend. This is not science fiction. This is a real effect predicted by Einstein's theory of relativity. It is called time dilation, and it has been measured many times with precise experiments. Clocks moving at high speed tick slower compared to clocks at rest. Even small speeds show tiny differences. Satellites in orbit already experience this effect. Their onboard clocks drift slightly compared to clocks on Earth. Engineers must correct for this every day to keep systems working. Now push that effect to extreme speeds. A spacecraft traveling near the speed of light would experience time very differently. For the people inside, time would slow down. Their seconds would stretch compared to the outside world. Their journey could feel shorter. Years for them might pass while thousands or even millions of years pass outside. At first, this sounds like a solution, a way to cross impossible distances within a human lifetime. But the truth is far darker. Time dilation does not reduce the distance. It only changes how time is experienced by the traveler. The rest of the universe continues forward at its normal pace, while the crew lives. Through a shortened journey, everything they left behind keeps aging. Earth would not wait. Civilizations would change, languages would vanish, entire cultures would rise and fall, continents would shift. Even the night sky would slowly transform as stars move and evolve. By the time the travelers reach another galaxy, the world they came from could be unrecognizable. It could be gone. And if they try to return, the situation becomes even more extreme. The return trip would add another vast stretch of time, more millions of years passing outside while only a fraction is felt inside the ship. When they finally arrive back, there may be no trace of their origin, no familiar signal, no shared history. The journey becomes one way, not because of fuel or distance, but because time erases the meaning of return. There is also a hidden psychological cost. Humans are not designed to exist outside of time in this way. Every connection to home, to history, to identity is tied to a shared timeline. When that timeline breaks, something deeper breaks with it. The crew would know that everyone they ever knew is gone, not lost in distance, but erased by time itself. Every memory becomes disconnected from reality. Every reference point disappears. They would not just be far from home. They would be of sync with existence. Even communication becomes impossible. Messages sent back would take millions of years to arrive. Replies would take just as long to return. A conversation becomes meaningless. It stretches beyond any useful scale. So while time dilation offers a strange kind of escape from long travel times, it replaces one problem with another far more profound. The body might survive, the mind might endure, but the connection to everything familiar would fade into silence. And beyond all of this, there is a force that makes the journey even harder. Because the universe itself is not standing still while any of this happens. There is another force at work. It is silent, it is constant, and it changes everything. The universe is expanding. This idea was first discovered when astronomers noticed that distant galaxies are moving away from us, not drifting, not slowly separating, moving outward in every direction. The farther a galaxy is, the faster it appears to recede. But the deeper truth is even stranger. It is not just galaxies moving through space. Space itself is stretching. The fabric of the universe is expanding, carrying galaxies along with it. Like points drawn on a balloon, as it inflates, every point moves away from every other point. This means distance is not fixed. Even as a spacecraft travels forward, the destination is also moving away. The gap grows over time. The journey becomes longer while it is being traveled. And at large enough distances, something extreme happens. Galaxies begin to recede faster than the speed of light. This does not break the laws of physics. Nothing is moving through space faster than light. Instead, space itself is expanding between objects. The distance grows so quickly that light emitted from those galaxies can never reach us. They are still there, but they are cut off. This creates a boundary in the universe, a limit beyond which information can never travel to us. It is often called the cosmic horizon. Anything beyond it is permanently hidden, and that boundary is not fixed. It changes over time. The force driving this expansion is known as dark energy. It is one of the greatest mysteries in physics. It makes up most of the energy in the universe, yet no one fully understands what it is. What is known is its effect. It causes the expansion of the universe to accelerate. This means galaxies are not just moving away. They are speeding up as they move away. The longer time passes, the faster the separation becomes. This has a powerful consequence. Some galaxies that are visible today will not remain visible forever. Their light will stretch and fade as they move farther away. Eventually, they will cross the cosmic horizon. After that point, no signal from them can ever reach us again. They disappear, not because they are destroyed, but because the universe has expanded too much. For any future civilization, the visible universe will shrink. Fewer galaxies will remain within reach. The night sky will grow darker, emptier, more isolated. This means there is a limited window of time to reach distant galaxies, and that window is already closing. Even if a spacecraft could travel near the speed of light, it would still face this expanding barrier. Some destinations are already beyond reach. Others will become unreachable in the future. The longer humanity waits, the fewer options remain. The universe is not just vast, it is actively placing limits on exploration. It is slowly isolating every galaxy, including our own, into its own region of space. And once a galaxy crosses that boundary, no amount of speed, no level of technology can bring it back within reach. But even within the regions that remain accessible, there is another problem waiting in the darkness between galaxies. Between galaxies, there is no safe path. It looks empty. It feels silent, but it is not harmless. Intergalactic space is filled with radiation. Cosmic rays move through this darkness at nearly the speed of light. These are not simple rays of light. They are high-energy particles, protons, atomic nuclei. Some carry more energy than anything produced on Earth. When they strike matter, they break it apart at the atomic level. On Earth, the atmosphere protects life from most of this radiation. In deep space, that shield is gone. A spacecraft traveling for millions of years would face constant exposure. Every second, particles would pass through its structure, through its systems, through any living body inside. Over time, damage builds up, cells break, DNA mutates, materials weaken. Shielding can reduce the risk, but it comes at a cost. Thick protection adds mass. More mass requires more energy to move. The problem feeds into itself. And then there are the smallest threats: dust. Tiny grains of matter drifting between galaxies, almost invisible, easy to ignore. But at high speeds, they become deadly. At a fraction of the speed of light, even a microscopic particle carries enormous energy. When it hits a spacecraft, it releases that energy instantly. The impact can punch through metal. It can create bursts of heat and radiation. It can damage critical systems. Now stretch that risk over millions of years. One impact might be survivable. Thousands might not be. There is no way to map every particle, no way to clear a path. The ship would move through a constant field of invisible hazards. Navigation adds another layer of difficulty. Inside a galaxy, there are stars, landmarks, gravitational patterns, signals that help guide direction. Between galaxies, there is almost nothing, just darkness and distant light. Precise navigation over. Millions of years becomes extremely complex. A tiny error in direction made early in the journey could grow into a massive deviation over time. The ship could drift off course by millions of kilometers, missing its target entirely. Correcting that error would require energy, constant adjustments, perfect precision. Then comes the question of survival. A mission lasting millions of years cannot rely on simple supplies. Food, water, air, all must be recycled perfectly. Without failure, every system must run continuously without breakdown for longer than any machine has ever operated. Even the smallest fault becomes critical. A minor leak, a software error, a material defect. Any of these could grow over time with no external help, no repair stations, no resupply. A single issue can become fatal. Human presence makes it even more complex. Life support systems must function without interruption. Biological systems must remain stable. Generations may live and die inside the same structure. Social systems must survive isolation, confinement, and time beyond comprehension. There is no room for collapse. In such an environment, failure is not dramatic. It is quiet, slow, invisible at first, then final. A single weakness can end everything. And even if every one of these dangers could somehow be managed, there is still one last hope people often turn to: a shortcut, a way to bypass distance, speed, and time altogether. When distance feels impossible and speed reaches its limit, the mind searches for a shortcut. Physics seems to offer one: wormholes. These are theoretical tunnels through space and time. Instead of traveling across millions of light years, a wormhole could connect two distant points directly. One step in, one step out. The journey reduced to almost nothing. The equations of general relativity allow such structures to exist. On paper, they are real solutions. They are not fantasy. They come directly from the same mathematics that describes black holes in gravity, but there is a problem hidden inside those equations. A natural wormhole would collapse almost instantly. It would close before anything could pass through. To keep it open, it would need something called negative energy, a form of energy that behaves in the opposite way of normal matter. This is not just rare, it is not even confirmed to exist in usable amounts. Small effects that resemble negative energy appear in quantum physics, but only at tiny scales. Brief, unstable, nowhere near enough to hold open a tunnel large enough for a spacecraft. Even if such energy could be created, controlling it would be another challenge entirely. It would need to be shaped, stabilized, and maintained for the entire duration of travel. One fluctuation, one imbalance, and the tunnel could collapse. Anything inside would be lost instantly. Then there is the issue of location. A wormhole must connect two specific points in space. But how do you place the other end millions of light years away? It would need to be created there first. That means reaching the destination before the shortcut can even exist. The shortcut requires the journey it is supposed to replace.
Another idea often discussed is the warp drive.
Instead of moving a ship through space, a warp drive would move space itself. It would compress space in front of the ship and expand it behind. The ship would sit inside a bubble, effectively carried forward, faster than light without breaking the speed limit. Locally, again, the equations allow this, but again, the requirements are extreme. A warp drive would also need negative energy. Not just a little, but vast amounts. Early calculations suggested energy greater than the mass of entire planets. Later refinements reduced the estimate, but it remains far beyond anything humans can produce. There are also stability issues. A warp bubble may be difficult to control. It could accumulate dangerous radiation at its front edge. When the bubble slows down, that energy could be released in a burst, potentially destroying everything at the destination. There is also no clear way to start or stop the process safely. Even steering becomes uncertain. These ideas are powerful. They expand the limits of thought. They show what physics might allow under extreme conditions, but they remain theoretical. They exist in equations, in models, in controlled assumptions. They do not exist as working systems. No experiment has created a stable wormhole. No engine has generated a warp field. No material has been found that can provide the required energy in a controlled way. So the final hope becomes the same as the others, a possibility that cannot yet cross into reality. And without that shortcut, every path leads back to the same conclusion. All of this leads to one clear and uncomfortable truth. The real barrier is not distance. It is reality itself. Every path to another galaxy runs into the same walls. Distance stretches beyond reason. Speed reaches a limit that cannot be crossed. Time breaks the meaning of the journey. The universe expands and pulls destinations away. Space itself turns hostile over long periods. Even the most advanced ideas remain trapped inside equations. These are not engineering problems. These are laws. And laws of physics do not bend for ambition. This changes how the future of humanity must be seen. The dream of traveling anywhere, reaching any galaxy, becoming unlimited in the cosmos begins to fade under closer inspection, not because humans lack intelligence, not because progress will stop,
but because
the universe has a structure that defines what is possible. That structure sets boundaries. It is likely that humanity will never safely reach another galaxy, not in a meaningful way, not in a way that allows return, connection, or survival as it is understood today. This does not make the universe smaller. It makes it more honest. There is still an enormous frontier to explore. Our own galaxy alone contains hundreds of billions of stars, worlds that have never been seen, systems that remain completely unknown. The local cosmic neighborhood is vast beyond measure, but it is also a boundary, a silent border drawn not by distance, but by the rules of existence. And that may be the most important realization of all. The universe invites exploration. It allows discovery. It reveals its secrets step by step, but it does not offer everything. Some doors are open. Others were never meant to be. Crossed. If this changed the way you see space and the future of humanity, take a moment to like the video and subscribe to the channel. There is much more to uncover, and the deeper the truth goes, the more surprising it becomes.